okay, if current val equals p dot val, no, I don't need to include it. Else, return find path for elif current val is less, yeah, because if the current value is less than p, wait, hold on. Yeah, if the current value is less than p, you go to the right one. No, you go to the right. And then if the current value is greater, then you have to go down, which would be left. Actually, no. Find path for, actually no, I could just do one general one. Find path for node. Yeah, because target.right. And then if I'm given two lists, I can iterate through them. I can iterate through them, and the second it diverges, then okay. Path for p equals find path for node. The target would be p path for q equals find a q. And then what we can do is iterate through the shortest one. Yeah, iterate through the shortest one. Actually, wait, no, we don't need to start the root. This is guaranteed to be out. And then what we could do is if path for p doesn't equal path for q, return answer, and then, or we could do answer equals that should be right. So if I'm given, yeah, so we get the path, we return it. Hold on, the reference should be the same, right? How does the memory work in Python? Yeah, it should be passed by reference, so therefore, I'm just not sure. Okay, just to be sure, in case there's some memory referencing issue, with classes that I forgot the quirk of in Python. Yeah, I don't think I'm missing anything. Yeah, I think this should be the answer. How can I test it? We just run it?
No, we won't be running this today. I'm too lazy to set that up. But I want you to convince me that's correct. So why do you think it's correct?
Well, the intuition behind my answer is to find the lowest common ancestor, we first need to find the path from the root to the respective P and Q node,
Mm-hmm.
and then when we get the path, we check the path starting from the root and see which ones they have in common. And the second is a divergence. Then we identify the previous one that there was alignment as the lowest common ancestor.
Okay. Can we talk about the time and space complexity of this function?
Uh, this is binary search, so this should be log of n. Well, the exact one would be 2 log n plus n. No, 2 log n plus n with n being the size of the tree. Because 2 log to get the paths for both of the to get the path for both of the nodes, and then n to it. No, this would just be this is log n. The depth is log n. My bad. Yeah.
So what's
Yeah,
your
this
answer?
should be 3 log n.
Okay.
This should be 3 log n. My bad. It's not n. 3 log n. Because at most this should be the deepest n. So yeah, 3 log n. Or specifically log n. That's my time complexity.
Okay.
And the space complexity, the only memory I use is to store the path, and the maximum that should be would be the depth of the binary search tree. Yeah. Oh wait, no. Wait, no, I'm actually so stupid. The maximum depth of a binary search tree given n nodes is n, because it'd just be a straight line. So the worst case, yeah. So the space complexity is 2 log n plus n, and then the space complexity is 2n.
Sorry, so what's the time?
The time complexity is log n.
Okay, and the
plus
space?
n.
Oh, plus n, okay.
Yeah, because I'm actually so stupid. The depth of the binary search tree of given n nodes is n. It's possible.
Yeah.
So yeah, and then the space complexity is just 2n.
Okay. All right. Okay, I'm happy with that, but I think we can improve on the space. I think it's possible to improve on the space complexity here. So I want you to tell me, why are we storing the paths?
Oh wait, no. Oh wait, actually, I think there is a slightly better way. I think there's a slightly better way in that we could basically find the path for one. Okay, so I'll explain the first question. I'm using an array to store the path because I need to track where where it's the same and where it diverges to find a common ancestor. And then I just realized there is a way to improve it. What I could do is basically traverse to find the node for only one of them. Is to basically traverse to find the node for one of them, get its path, traverse using the path, and then see at which point is the path for one of them diverges. That's one optimization.
What would the resulting complexities be for that optimization?
The resulting complexity would just be 1 log n.
Okay.
Wait, hold on. Yeah. Plus. Yeah, 1 log n plus m with m given how long the path is for one of the nodes. Yeah, that's one optimization technique I could think of now that I think about it.
Okay, but we're still storing a path. Why are we storing a path? This is still the fun with the question.
Okay, is there a way to do it without? Is there, yeah, so is there a way to do it without without storing the path? Let's think. I use the paths to keep track of 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 the ancestors of both P and Q, so I know where it diverges on the binary search tree.
How else can you know if it
Uh,
diverges in a binary search tree?
hold on, let me just take out let me just like pull up Excel I draw and just view it.
Yeah, you can go to the drawing tab for that.
Wait, there's a drawing tab? Okay, yeah. Oh no, where's the circle?
You can just use a pen. It's okay. It's like you don't have to actually draw the circles.
Uh, and then yeah. And then let's say these are my ones. And then this. Could I tell just when I traverse, can I just tell by the value? Can I tell just by the values? Okay, let's say I'm traversing to find one of them. When I go here, let's say I'm traversing to find one of them. Let's say and then if I'm already here, is there a way to know that there's a divergence? Because we know, okay, so we know that the current value is high, so we know P is higher than the current value, but Q is less than, but then the parent, oh, because Q is less than the parent, wait, hold on, if P is, if I'm on node X, we know for sure it's an ancestor of P. Let's see, so how can we know Y is an ancestor of Q and P, but X is only an ancestor of P? Q is less than Y. Is it because it's increasing?
So just to be clear here, what is the correct answer in this example?
Y.
Okay, good. So what is a property of y that is not a property of previous nodes in the graph or the tree? Sorry.
Wait, the previous ones are ancestors, though. Its
Yes,
ancestors are ancestors.
but they're not the least common ancestor.
It's the furthest from the root.
It
Oh.
is furthest from the root. What do you mean by that? It is the furthest ancestor from the root. Is that what you mean?
Like it's the deepest from the root. Yeah, it's the deepest in the tree.
Yes, that is a definition of the lowest common ancestor. That is a definition, correct? Now, I'm thinking about the specific property of the numbers, right? Like, what is a property of the number there? That I'll draw this out for you a little bit. So, use a pen here. So we have a number over here, right? This is your number. What is a property of this number that is not a property of this number? Or I'll put another way. What's the property of this number? Actually, okay, let's do it the easier way. What's the property of this number that's not a property of this number?
Wait, hold on, but we don't know if it's left or right though in that context.
What do you mean you don't know what's left or right?
Wait, no, but it's just a pair, but we don't know if it's. But the parents in my example has only one child, so we don't know if it's. Oh no, we do know if it's the left or right one. Yeah, it has to be one of them. It has to be left or right. I didn't specify whether it's the left or right child of the parent. So one property Y has. Maybe we can think about this as intervals.
So let's come over here. So let's call this A.
Yeah.
So we have Q, A, P, and there's two symbols here. The symbols can be less than or greater than. I don't want you to fill that in. Okay, so there's four questions for you here. Please fill that in.
There's four what?
So there are four relationships here, right?
Oh.
Please fill that in.
Okay. A is greater than Q, and A is less than P. Oh.
Are you sure about that?
Hold on. Hold on, but I didn't specify whether Y is the left or right.
If Q is less than A, what does that imply though?
Oh, if Q is less than A. Wait, hold on. Because I know, yeah, Y for sure is diff.
So we're assuming that Y is a left subtree here. Is that the assumption? Because you said Q is less than A.
Yeah, sure. Let's just assume Y is the left one.
Well, hold on. We don't have to assume it. I'm just saying, if you put less than over here, this must be the left subtree. Why A cannot be bigger than, or A cannot be less than Q if it's in the left subtree. Like this is a binary search tree, right? This is a binary search tree. Okay, just so we're on the same page. Okay, so Y is a left subtree.
Yeah, so that
and
means
so
Y
A is bigger than every value in the left subtree.
Mm-hmm.
Right?
Yeah.
Okay, just to make sure you're convinced. So A is bigger than P, correct?
Oh yeah, my bad. Yeah.
Okay.
Yeah. Okay. Yeah. I agree.
Okay. So what are we noticing here? So what is a property? The property we're noticing here is unique. It's not unique to the Y value, which is our goal to discover, but it is the first node in our sequence in what we previously called the path to fit this definition. Okay?
Right. Yeah. Yeah, that makes sense. Oh. Yeah, that. Oh, that's. Oh, yeah. Oh, okay, yeah, that makes much more sense. Yeah, because initially A was greater than P, but now Y is less than P. Oh, when the signs flip, then it's the lowest common ancestor. Okay, that makes much more sense now.
Okay,
Yeah.
let's see you implement it.
I think it has to be recursive. Wait, hold on, but I do need to... Wait, no. I don't need to know which one. What I could basically do is... Wait, hold on, but how do I know when to go left or right? Let's call this one Z. The properties of Z is that... Yeah, the properties of Z... It's greater than P and greater than Q. Okay, that's the property. If one node is greater than or smaller than both of them, if one node, yeah, so basically if a node is smaller than or greater than both of them, then it can't be an ancestor, but if it's between them, wait, hold on. But A is greater than...
So the specific property we're looking for here is we're looking for the first node, which is between P and Q.
Yeah. Oh, okay, the first one that's between. Okay. Whereas A is always... Okay, so our algorithm will know to pick Y. Wait, hold on. Wait, hold on. But that's only because it's... Wait, let me just draw another one just to see. So, root A, B, C. Yeah, and then Q and P. How will our algorithm know whether to go left or right in this case? In this case, B would be greater than Q and P, but so is A. But so is A. Oh, no, but so is A, so we choose them. Hold on, so if they're both greater, we choose the minimum. Wait, so if we, no, because if they're both greater, we go, if they're both greater, we go left. But what if it's the, but what if it's the right of A? If it's the right, yeah, hold on, this takes some figuring out. Because if A is the right of both Q and P, that means A is less than P than Q. When we have these
Oh, hold on.
ones,
Say that again. If in this case you're saying, I mean, so in this case you're saying, right?
yeah.
Uh,
So when it's right,
so
yeah.
A
This is when it's
is
yeah. This
so
when it's left.
but so in this case A is greater than P.
When it's the left. When it's left. That's what I wrote here, I think.
Yeah. Well, what's this supposed to be?
I'm just writing the scenario when it's actually the right child, because then the inequalities change.
Right. Yes.
Yeah, that means their A is smaller. This will take some figuring out with the conditionals. So if they're both greater, than the targets, you choose the left. If one of them is, wait, no, but if one of them is smaller, okay. So basically, that makes sense. When both of them are greater than the targets, you obviously choose the smallest one. But what if it's in between? What if it's to the right or to the left? What if it's to the left or to the right?
Okay. I want to pause on this for a second. Um, there's only there's really only three conditions. Okay. The
Yeah.
three conditions are if your current node, and talk about values, okay? If your current value is larger than if your current value is larger than the largest value, okay. So if your current node is
Okay.
larger than the largest value, then you go left.
Okay.
If your current node value is less than the lower value, than the lower value between P and Q, then you go right. And
Okay.
then the moment your value is in between P and Q, that is your answer. Those are the only
So
three
basic.
conditions.
So basically, if the lowest. So basically, if the lowest value. So basically, highest target larger than current. Go.
No other way around.
Go.
No other way around. So in this case, I wanted to say this without loss of generality. Assume Q is less than P. Okay.
Yeah. Okay.
If your current value is less than Q, go right.
Oh, so if the smallest is smaller, go right.
What's the highest you're supposed to mean?
Never mind.
Okay.
If this
Yeah. So the smallest. No, the smallest is larger than the current one. Go right.
this yeah, if the smallest is larger than the current one, go right.
Yes, and the largest is smaller.
Okay, yeah. So
Right. So let me just so let's draw this out. Right? We're basically saying, hey, we're trying to traverse our current node through the tree.
mhm.
Right. So look, I'm looking at the drawing pad here. So, in this case, we have Q and P over here, which makes sense. Over here, we are larger than P. We're larger than the largest one, right? We are larger than P, right?
Right.
If we're larger than the largest one, in this case, in other words, the largest is smaller than the current one. That's always say, right? The largest, which is over here, is smaller than the current one, right? Understand? Yeah. We go left,
Yeah.
right?
Okay, that makes sense.
Okay. And then over here, and then if you look at this, so now we're at A. What's going on with A? A, we're saying okay, A is still larger than the largest one, right? Because it's the left subtree, right?
Mm-hmm.
So we still want to go
Then you
left.
decrease it. Okay, that makes sense.
And then now when we're over here, right, our target node, it is between Q and P, so we're done.
Mm-hmm. So current.val. No, it's unique. So if current.val is smaller than min of Q, E dot value of tree return traverse tree current. Yeah, because no, you go right. If the current is smaller, yeah, if the current is smaller than this, you increase it. If the current is smaller than the largest value, you decrease the current. You decrease it, else you return the current one. Yeah, that should be the answer.
Okay. So what is the time and space in this case?
Log, yeah, log n time complexity, and this, and then the space complexity is O of 1. Of whatever the size of the tree is.
Can you repeat that? It's whatever
The
the
space
size.
complexity was whatever the size of the tree is.
Okay, and why is
Nothing
that?
more. Because because the tree is stored into memory, but my algorithm doesn't take additional memory.
So the overall space is
Just O of 1 then, if you don't
O1.
include the tree. Yeah, if you don't include the tree, just O
If you
of
don't
1.
include the tree, it's O1. Okay. So you are using a recursive algorithm.
Mm-hmm.
Okay. What is a property of recursive algorithms that use space complexity?
It adds to the stack.
Correct.
Oh, wait a minute. So the space complexity is whatever the depth of the tree. Yeah.
Okay,
So
so
the space complexity is the maximum. Yeah, the space complexity, worst case scenario, will be the maximum depth of the tree.
which is?
The worst case would be O of n with n given the amount of nodes.
Okay. So how can we not have a stack?
Don't use recursion and just use iteration.
Correct.
Oh, it's just that I mostly use recursion, so... And you'd like me to do it with iteration, right?
Well, I would like it to be more optimal, so whatever it takes.
Yeah, you know what? While answer.val... You know what, let's just not overcomplicate ourselves. If per answer dot val per answer equals current answer dot right elif per answer dot val is greater than the max per answer dot left else just return correct answer. This one shouldn't clear. Yeah, this one should be O. This should be constant space complexity.
Okay. Okay, and that is all. That is all. So at this point, I want to end the mock and then go into the feedback and the questions. So I just want to start off here by just asking you, how do you feel about this question? How do you feel about how well you did? Strengths, weaknesses, from you first.
Yeah, I think this is a really good question. It's a really fair question. It does challenge me. The first one I did, the first one I did. So I guess one strength is I did find an answer. I did find an answer relatively quick. But I didn't. Oh yeah, I guess one weakness is I didn't communicate. Yeah, well, I guess one weakness about my approach was I just simply implemented whatever the first solution came to mind to find the answer. What I should have done was come up with whatever my answer was first and then ask myself how to optimize it. Then I write the code. And then, yeah. Instead of writing the code of the first answer that came to mind, what I should have done was write the code, was think more deeply on how I could further optimize it. The first one, my answer was about double the time and complexity of the most optimal solution. The second most optimal answer, I feel, was the second answer. Yeah, the second answer was a lot better, was a lot closer to the most optimal solution. But I guess one weakness of me was that I couldn't figure out the intuition behind the most optimal answer, and I definitely did need a hint from you on the conditions of the traversal.
Yep. Yeah, I think that's pretty well in line with a lot of the stuff I was thinking along the way, right? Same things, which is you had an idea, right, and it worked, and that's fine and all, right? That's step one. So you're at step one. That's good, right? And then of course the hard part is everybody gets to step one. The real challenge begins after that, right? And like you said, that's where it kind of fell apart a little bit, right? I will give just a tip just right off the rip here, okay? You actually recognize yourself that there's some conditional stuff going on here, right? You said conditions of the traversal. I like that term, okay? Whenever you find yourself thinking about these conditions and you don't have a clear answer, I recommend you just immediately start drawing out a table, thinking about all the different conditions. Because if you think about it, and I think you actually understood this relatively early on as well, is that there are actually only 4 conditions, even if you take all the permutations, right? The current node is either to the left or right of the smallest node, and it's either to the left or right of the largest node. That's 4 possibilities at any given point, right? If you think to yourself, oh, there's only 4, your first thing to do is you should just immediately draw it out. And then from there, you will quickly realize, because it's a binary search tree, there's actually only 3 conditions, which is you're either to the left of the smallest one, between them, or to the right of the largest one. There's only 3 conditions. So I think if you just jump down the drawing a little bit more, jump down the drawing the table out, that would have helped you a lot in this case. Okay, because it's not that you're stupid. It's not that you couldn't figure it out. It's that you couldn't figure out how to get started. That was the issue. Okay.
Yeah.
So
I see.
As a strategy, and this is not just for tree problems, obviously. I mean, in general, just as a strategy, whenever you see that there's not that many different possibilities, not that many states, we call it, right? Just start drawing that out, and that's going to help you a lot in the long term. Because even if you don't, in the worst case, the interior can step in and say, hey, in your current situation, this is what's going on, blah, yada yada, right? That helped us in our case as well, right? When we had the drawing open and you drew your second one, I was able to step in there. Right. So yeah, although that would be considered like as a pretty major hint given to you, that is still better than not getting a hint and not solving the problem. So I would say, hey, lean on the side of just doing something, drawing something out. That's gonna help you a lot more, just in general. So once you got there, you kind of got the problem pretty quick. But of course, you did need a couple of hints to kind of get there in the first place.
Yeah.
I did also want to comment a little bit about. Want to comment a little bit about some of the earlier things in the session. So this is another piece of feedback I want to give, which is I think you thought of an answer really quickly, and that's really good. And then you kind of just started implementing things right away. And I think, like you said, I want to echo what you said is, hey, maybe slow down a little bit. Think about maybe there's something better to do, right? And in general, I would generalize it a little bit more and just say, hey, get a bit of buy-in from the interviewer, okay? Like, hey, here's my process, here's my algorithm, here's what I plan on doing. Hey, what do you think? Do you think this is good? Should we spend a bit more time thinking about that, right? Like, there's a little bit more there you can interact with the interviewer on to just help them along, bring them onto what you're thinking, and that gives them an opportunity to comment if they so choose on your algorithm, right? Like
Yeah.
if they like what you're doing, then I mean, obviously no problem, continue on. If they don't like what you're doing, they have a chance to step in and kind of guide you up from the get-go. Okay, so it's like a no lose scenario for you to just ask that just off the rip. So I would recommend you start doing that as well, and that might have helped you clear up a little bit more in this problem. Okay,
Yeah.
and then sorry, were you gonna say something there?
I just said, yeah.
Okay. And then last thing I want to comment on in this case was about the time and space complexities. Okay, so time and space complexities. First of all, a couple things I want to say. This is dependent on the interviewer, but I like that you gave me the constants. Okay, I like that. I like that you were precise with the constants. I thought that meant that you were very clear in your mind about what's going on, and I think that it's also very good that you caught on to the worst case, being that this is not a balanced binary search tree, right? This could be a skewed one. And you caught that on very good with the in instead of login. So I thought that was well done. One thing I will say though, as a little strategy thing for you as well, is you don't, like, whenever you're asked for the time and space, you don't. It's not like you have to give it right there on the spot. You can think about it. You can work through the problem a little bit, right? So what I would do for you is, hey, you have the knowledge to solve it correctly. Take an extra 10 seconds just to walk through it, just to think to yourself what's going on, right? That way, when you do give it an answer, it is a great first impression. Okay, like it's not great to be like, oh, here's an answer and it's like mostly correct, but then you got to correct later on. That's not as good. Okay, so just
Right.
just take the 10 seconds. It's totally okay. Take the 10 seconds and then come up with a more polished answer. And of course,
Yeah.
a little detail that at the end, you forgot about the call stack. The call stack, that is something which does trip people up, obviously. And it's not like you didn't know about the call stack. And once you were reminded of it, obviously that, and then you were very quick to point that out. But again, this is one of those things, right? Take the 10 seconds, and then just think through it. Hey, this is recursion. Recursion means there's a call stack. What is the depth of my call stack, right? So just take the minute to think about that. That's always going to help you out. And I'll give you another tip. If you're thinking even higher level, before you implement recursion, you should think to yourself, oh, this is going to be a recursive function. All right, I'm going to take a mandatory space complexity here. Is this space complexity also going to be required on the iterative solution, right? If it is going to be required on an iterative solution, then it's okay. If it's not, then you want to pause and think about it, right? At the very least, you want to call it out. Hey,
Yeah.
I'm going to use a recursive solution here. I know this is going to use some calls, some space on the call stack. I'm going to just go ahead with this unless you have any concerns. So again, right, just call it out to 10 seconds. It's going to go really far. So it's not lack of knowledge, right? So you're already most of the way there, but just a bit of strategy for you.
Yeah. Okay. Thank you so much. This is really, really helpful.
Cool, great. That's all the feedback I had. Of course, I'll send you notes after, but I want to open up. We have like 5 minutes, so I want to give you some space. Any questions about this interview, this question, or just about anything in general?
Yeah. I mean, I was gonna say whether this would I guess one question I asked is, does this constitute as a pass?
So I would say that is dependent on the bar of the company and the interviewer. So I'll tell you what went well this interview. A couple of things went well is that we did get to the correct answer at the end. That is a good thing. So that's, for a lot of companies, that's going to be basically the major indicator. Okay, but let me tell you, like I said, the feedback wise, a couple of things I think could be improved. The first thing was the time control, right? Like, we did take up a lot of time, and I think, like I said, a lot of time could have been saved had you checked in earlier with the interviewer about proceeding. Okay, so I think that would have saved a lot of time. We could have gone through some more follow-ups in that case. And I think you did confuse yourself quite a bit with the states. So in this case, if this interviewer was more focused on technical execution, that might be a tough sell, because you did miss a critical part of the traversal of the states. Now, on the other hand,
The conditions, right?
the conditions, correct, yes.
Yeah.
If, on the other hand, the interviewer was more concerned about technical communication and, let's say teamwork, that might be a bit of an easier sell, depending on what they were looking for specifically. For example, you were quite receptive to the hints, right? You took the hints well. You were thinking about them. Now, I would have liked you to have taken the hints further. In this case, in this problem, I gave 3 hints. I would expect after 1 that you would be able to solve the problem, right? In this case, the
Right.
specific hint would have been when I drew out the first conditional block with the QAP, right? With this hint, I would expect you to solve it by yourself from this point onward, right? But you took 2 more hints,
Hmm.
so that might have been, depending on some interviewers, they might view that as a negative. But I think
Yeah.
on the whole, this would have been a bit easier sell on the communication aspect than it would be on the technical execution part, if that makes sense.
Yeah. Okay, thank you so much.
Okay. If there's nothing else, then we'll call it here.
Yeah, okay, thank you.
Thank you very much. Take care.
Bye.
All right. That is that. I actually ended up a bit early. Just chill. Send them notes. And we will get to the resume review soon. We're a bit early, so I'm going to just take a little break here. Where's my text? Here we go. 05. Boom. And then is my thing pinned? I don't think so. Resume review form. Boom. And then live stream. Pin. Oh, I can pin on Twitch too, right? Let me see. On Twitch. Ah, there it is. Cool. All right, I'll be back in a bit. right, we are back. We are back, and we have 2 submissions. Okay, looks good. Let's take a look. All right, so graduated this May, actively seeking SWE new grad, focus on backend and cybersecurity. Oh, interesting, cybersecurity. Okay, okay. Okay. Real learning platform, college students what haptics lectures on their schedules. Okay. User-friendly web learning platform USF, John Hopkins, leveraging React, Big Blue Button, virtual video conferencing. Leveraging, okay. It's a bit vague how much of this was. It's a bit vague, like how much of it exactly was from your contribution. Like, for example, did you build the entire thing, or did you just contribute to it? Yeah, 30% of their head. Okay, that's good. Academy. Job tracking. Okay. Java size bundle. That's good. Okay. Crypto enthusiast. 3-tier API fallback. CoinGecko. Some stuff. Okay. Huge engagement with this trending crypto filters, price realization, real time news optimization. Okay, interesting. Okay. So there's like a back end here and a front end, and there's a link here presumably. So okay. Boosted user engagement with trending field. Okay, sure. Okay. Okay. Accuracy. Okay, so little bit of okay, so a little bit of what do you call it? Okay, so yeah, okay, so there's a little bit of data science related here. Some network X Python damage. Okay, Terminator, a hackathon, a lot of skills. Okay. Cybersecurity is a weird one. I'm not sure where this ties into cybersecurity. Right? Did you mention that? Yeah, I'm not sure where the cybersecurity part came from. You have some certs. I think cybersecurity, generally speaking, they want to see a bit more than just certs. I would, for example, expect to see some CTF club performance, that kind of thing. There's a lot of online CTFs now, that kind of thing. That's where I would expect to see some cybersecurity credentials. Otherwise, these 2 projects, I think you would have to I have to see them to know what's going on. For example, this project doesn't seem super relevant for software. This feels like it's more like data science related than like SWE. That could just be me, but I'm reading this a lot into like classification, scripting, that kind of thing. I don't think this is super applicable for SWE. Backend wise, you have some backend over here as well. You have Node, PHP, Mongo, so there's some stuff sprinkled in there. A little bit of front end as well. I think this is generally like a full stack resume. I wouldn't say this is too focused on backend. I definitely wouldn't say this is too focused on cybersecurity. But that's just my reading. Okay, let's take a look at the next one. Next one has this person's freaking name on it. Guys, please. Alright, I think that's all there was. Let me just see. There was a guy who sent me one earlier, so let me go find that one and then see if I can review that. If there's nothing else, then I'll just call the stream here. But let me see if I can find theirs first. Where the hell was this thing? Was it this guy? No, but this one looks relevant, so I can talk about it. Okay. All right. So, this guy's comment: looking for junior dev. Applied to over 300 in the past few months. Haven't got many responses. Okay. Okay. So scalable. You can generate Excel files under 6 minutes. 30 expand. Okay, this is a good data point to start. Refactored core Java service to adopt asynchronous programming models and offload computation-heavy tasks to underutilized K8s managed clusters or servers. Improving throughput, responsiveness during peak usage. I like that. In-memory services to stream-based pipelines, scalable file handling, reducing file processing time. Okay. Redis Mongo-based backed session. Okay. Flexible client-specific asset control. I like that. That's good. Abstracted marginalized business logic code, blah blah blah. Okay, this is like a more mediocre point, but it's all right. Pretty strong showing over here. I mean, this is pretty good so far. Backend developer contract, comprehensive Django, web app to efficiently manage 40 gigabytes of product inventory. Student supervisor data, intuitive CRUD operations. Intuitive CRUD operations. Okay. It's an interesting adjective, not challenging it, but that's definitely a choice. Design an initial database schema. Support scalable, normalize. Okay. Initial is interesting. I'm assuming it was improved later on, but yeah, that's accurate, I suppose. That's good to have. Implemented advanced filtering, search functionality, streamline, blah 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 blah. 7%. Okay, that's good. Good data point. YouTube API. This is a weak point. I mean, that's fine, but that's fine. Let me see the rest. If I see the rest, then it's fine. Okay. Internal tooling, utilizing Lambda, Glue Spark, SNS, Dina. Enabling internal customers to query about 100 gigabytes of data within minutes. Reduce data query time, 50% leading to improved data-driven decision. Okay, I like that. It is CDK code base. Okay, I think I know where this is now. It's pretty good. UI, Angular. This is definitely weaker. I might cut this point down a little bit. Like a fewer points there. Bachelor of Engineering. Let's take a look. What is it? Technical leadership. Client. This is a bit weaker, but I think that's totally fine to put in. I would split out into different languages. Ruby, Bash, Quarkus. I think the resume is actually pretty decently strong. I just think that once you get into the like junior and not the new grad section, the difficulty is up the ramp because you're competing against way more people. I would say honestly at this point you're better off spending your time and effort doing like going to networking events, meeting people, going to school events, even like meeting other mentors and whatnot who go there. The working on the resume is going to give you diminishing returns. Like your resume is strong enough as is. I wouldn't really focus on this further, but it's just about time management at this point, I think. All right, that is all the resumes. Let me just check the spreadsheet again. That's all of them. Yeah, that was all of them. All right, then in that case, I'll end the stream here. No need to drag it on. Take care, everybody.